Welcome to the podcast on significant digits, accuracy, and precision. In our course, we're going to be dealing very heavily with calculators. We'll be using them every day. And when you do a computation involving a calculator, you often get a very long string of digits in your answer. We need to know, as mathematicians, how many of those digits are really reliable. There are two types of numbers we'll deal with. Exact numbers are numbers which result from counting, like 5 people in the room, or they come from definitions, like 12 inches in a foot. When our computations are using exact numbers, we can keep all the digits that our calculators produce. But there's another type of number called approximate number. An approximate number comes from a measurement. When you measure things, by the nature of measurement, you always have error involved. So it turns out that many of those digits that are produced when we compute with approximate numbers, we cannot keep. This podcast is about what you can keep, what you cannot keep. In order to get us to that point, we need to have three concepts: the concept of a significant digit, and related to that, the concepts of accuracy and precision. So let's begin. What do we mean by a significant digit? There are 4 things that can make a digit significant. Number 1, it is significant if it is not 0. So if you take a look at my first example over here, the number 2300 has 2 digits that are not 0. So we say it has 2 significant digits. I'm not going to write out significant digits. I'm just going to put SD because it takes too long to write that out. The second condition for a digit to be significant is if it's the last digit to the right of a decimal. So take a look at my second example. The last digit to the right of the digit is that 0. So even though that's not a non-zero number, it is significant because it is the last digit to the right of a decimal. So this number would have 4 significant digits. A digit is also significant if it's located between 2 significant digits. So take a look at my third example. In my third example, the 2 and the 3 are significant because they're not 0. This last 0 is significant because it's to the right of the decimal, the last digit to the right of the decimal. All of the other zeros are between these significant digits. So this number would have 6 significant digits. All of the digits are significant. And finally, it is significant if it is marked significant. We'll talk a little later about why something would be marked significant, but for right now, these 2 digits are significant because they're not 0. If I mark this digit significant, it now becomes a significant digit, which means that this digit is between significant digits, so we have, in the last example, 4 significant digits. Now before we go into rounding, let's recall briefly about decimal position. If you have a number like 4,234.050, the 4 represents 4 ones, the 34. The 30 represents 3 tens. So as you start from your decimal and move to the left, you get ones, tens, hundreds, thousands, etc. If you move to the right, you go smaller. Smaller than ones would be tenths, then hundreds, then thousands. Each time I'm adding 1 0 in the denominator. Now, with that in mind, let's talk about accuracy and precision. When we talk about rounding by accuracy, the accuracy of a number is the number of the significant digits in the number. So 203 has an accuracy of 3 significant digits. Precision of a number refers to the decimal position of the last or the rightmost significant digit. In the number 120.20, the last significant digit is this 0 because it's the last digit to the right of a decimal. That's in the hundredths position. So this is precise to the nearest 100th. Now every number has both an accuracy and a precision. So I've listed 4 numbers here. We're going to look at their accuracy and their precision. The first number, the first 3 digits are significant because they're not 0. This 0 is not to the right of a decimal, so it is not significant. Therefore, this has 3 significant digits of accuracy, or we say it is accurate to 3 significant digits. Now, what is its precision? Well, The last significant digit here was the 5. The 5 is in the tens position, so we say it's precise to the nearest 10. Take a look at the second example. What is its accuracy? How many significant digits does it have? Start counting significant digits always with the leftmost non-zero digit, which would be the 2, or the first non-zero digit. Then count off to your right to get significant digits. If there's a decimal, just count to the end of the number. So we have 1, 2, 3, 4, 5 significant digits. How about the precision? Well, this is our last significant digits. It's in the 10,000th position, so it is precise to the nearest 10,000th. Now, I'm going to want you in just a second to pause your video and you fill in the last 4 blanks. And then when you start your video back up, those 4 blanks will be filled in and you can check your answers. Okay, pause your video. Okay, we're back. Check your answers. Now, if you got those answers correct, you're doing great. If you didn't, be sure you ask about them next class if you can't figure out what you did wrong. Okay, let's start rounding. The first rounding we're going to do is going to be a precision rounding. This is the rounding that you've always done. We're going to do more though than just round. Once we get the number rounded, we're going to determine what's the maximum error in this rounded off number. And the maximum error that you can have when you round a number is 1/2 the value of the decimal place of the last significant digit. So let's begin. The first one says round 0.3010 to the nearest hundredth. Here's the hundredth position, so we're going to be rounding to that 0, so we're going to be looking at that next digit over, which is less than 5, so we'll just drop off those last digits, 2.30. Now, what is a maximum error that would result from the rounding that we've done? Well, we say it's half of the value of the last significant digit. The last significant digit is in the hundredth position, so it would be half of 100th. Now, if you don't know what half of 100th is, do the following. Go to the next position, which would be the 1000th, and put that as your denominator and put a 5 on the top. And that would be half of 100th is 5 thousandths. So we would say our answer is 2.30 plus or minus 5 1,000th. The second one says round the same number to the nearest 10,000th. Well, here's the 10,000th. And it's already rounded to that, so that's done. So what's the maximum error of a number rounded to the 10,000th? Well, go to your next position over, which is 100,000th, and again put a 5 in the numerator, half of a 10, and you get that it is 2.3010 plus or minus 5 100,000ths. We can only be off by as much as 5 100,000ths. Now, we said earlier that we were going to talk about marked significant. So let's go ahead and do the next 2 examples, and that'll illustrate why we mark a number significant. The first number is 23,999.5, and it says round to the nearest thousand. There's no th. The thousand is here. So we're going to round to the 3, so we look to the next digit over, which is 5 or more. So we're going to say 24. We're going to round up. Now, if I leave it like this, the 4 is in the ones. We weren't rounding to the ones, we were rounding to the thousands. So to make sure that 4 is in the thousands positions, I add 3 zeros. What's our possible error? Well, half of the position that we rounded to. We rounded to the thousands, so we could be off by plus or minus 500. The next example uses the same number, but we're rounding to the nearest unit, or 1. The 1 is right here. To round to there, we look at the next digit over. Since that's 5 or more, we're going to round up, but we can't put a 10 there. We can only put 1 digit there, so we put in a 0 and we carry a 1. And we have the same position. We get a 10, so we put down the 0 and carry the 1. Again, we get a 10, so we put down the 0 and carry the 1. So again, we get 24,000. What's our maximum possible error? Well, it's half of a unit this time. A unit is a 1. Half of a 1 is just a half. So this last number is much more accurate than this one. This one could be off by 500. This one can only be off by half. How do we indicate that? Well, that's where marking a digit significant comes in. If it looks like you've rounded to the thousand, but you really rounded to the unit, then mark the unit significant like that. And then you know that in this number you might be off by 500, but in this unit number you can only be off by a half. And now we come to the part that really all of this is set up for. Rounding by accuracy, rounding by significant digits. This is what you'll be doing the most of. We're going to learn just to round, and in the next two videos you'll learn how that applies to actual computation. So let's start. It says round 2.3010 to 3 significant digits. Again, your first significant digit is your first non-zero digit on the left. So there's your first significant digit. So 3 of them would round to the hundredth, so we get 2.30. That's because the next digit over was a 1, so we're rounding down. The next one says round to 5 significant digits. That is 5 significant digits, so we're done. The next one says round to 3 significant digits, and 3 significant digits starts with the first non-zero digit on the left, which is a 3. So if you count off 3 of them, that means we'll be rounding to right here, to that last 9. Well, the next digit over is a 5, so we'll get a 10, so we'll put down a 0 and carry the 1 to the next 9, where we get a 10, so we put down the 0 and carry the 1 to the 3, where we get a 4. But if I leave it here, the 4 is in the hundreds position. It's supposed to be in the hundredths position, so I put a 0 and a point, and that puts the 4 in the hundredths position. Notice I do have 3 significant digits. This is significant because it's the last digit to the right of a decimal, and the center 0 is significant because it's between significant digits. And finally, this last one says round this to 5 significant digits. We don't have 5 significant digits to round it to, so we simply can't do that. So I'll just put here, can't be done. Now, in just a second, I'm going to tell you to pause your computer. When you do that, I'm going to put in the final answers here. When you turn your podcast back on, you'll see those answers and see if you got them correct. Are you ready? Pause your computer. Okay, we're back again. Here are your 4 answers. Check and see if you got them right. If you didn't get them right, try to figure out why. If you can't figure out why, be sure to ask about it the next time you have a class. That completes our Rounding Significant Digits Accuracy and Precision podcast.